A conductor wire of length 24 meters has a resistance of 16 and conductivity of 3.1 times 10 times 10, that is ohms per ohms per meter. The cross-sectional area of a conductor wire is 3.2 times 10 power negative 2. That is the cross-sectional area of the wire. Resistivity is 4.0 times 10 power negative 4, that is ohm meter, and a resistance of 8.0 times 10 power negative 2. Then we are taught to determine the conductivity of the wire and the length of the wire in meters. So in this question we are talking of conductivity, resistance, and the resistivity, and you have to know the relationship between these quantities. So for conductivity, we will use the sigma. Then for resistivity we'll use the rho. Then resistance, we normally represent resistance using capital R. And the relationship between conductivity and resistivity is, to get conductivity you take the reciprocal of resistivity, and to get resistivity you take again the reciprocal of conductivity. So given either of them, you can get the other by taking the reciprocal. So to start with, according to our question, we are taught to determine the conductivity, and the resistivity is being given. Actually, these values in the first statement will never be used in this solution. So our resistivity is 4.0 that we are going to use, and 10 power 4, because in the second statement is where now we are given the rest of the values that depend on each other. So we are using the values in the second statement in the question. So the resistivity here is 4.1 times 10 raised to power 4. So our conductivity will be the reciprocal of this, which is 1 divided by 4.0 times 10 power negative 4. So when you multiply this, when you divide, you'll get 2.5 times 10 power 3, and this will be per ohm per meter. So that is the conductivity. We can go to part B. Part B is asking us of the length of the wire, and we are going to utilize the relationship, which is, so here we are talking of, the question is talking of area, cross-sectional area. It has also the resistance, and we have the resistivity. So we have the relationship that resistance is normally directly proportional to length and inversely proportional to cross-sectional area. So our resistance, when we introduce a constant of proportionality, resistance is given by rho L over A, where this rho is the resistivity that has been now given. So we are calculating the length. So our resistance is 8.0 times 10 power negative 2. We equate these two. Our resistivity, which is 4.0 times 10 power negative 4. We multiply by the length, which we don't know, that we are calculating, and we divide this by the area, which is 3.2 times 10 power negative 2. So to get length, you can multiply both sides by 3.2 times 10 power negative 2 over 4.0 times 10 power negative 4. So when you multiply both sides, this side will be left with L and the other side will have 3.2 times 10 power negative 2 over 4.0 times 10 power negative 4. Then this is multiplied by 8.0 times 10 power negative 2, because we were multiplying both sides by these values. So now so we have these two in the numerator and we have the resistivity at the denominator. So when you compute this, when you multiply this, you will get 6.4 meters. So you can try to compute this and you'll get this 6.4 meters, which is our length. So what is important here is know the formula and substitute the various values that you have been given and you'll get the unknown values.